Hey guys, we're going to talk a little bit about precipitation today and formation of, or just the rules for solubility and insolubility with respect to water, just because I did a very poor job explaining this in lecture. So we're going to see if I can explain it a little bit better over the powerful interwebs. Really real quick, share my screen as per the usual. Go to the paint. Let's see, make sure that it's working. Yay, it do look that way. Hope everyone's having a wonderful Friday in spite of the cold. Let's see. Make sure this looks good. Good. Okay. All right. So again, just to frame this a little bit. When we're talking about solubility and insolubility, this is within the broader context of precipitation. So what can happen sometimes is I'll have, let's call it anion 1 interacting with cation 1. And then I'll have cation 2 interacting with anion 2. Okay. And I'll put those into interaction with each other, right? And then they will form some kind of recombination. So I'll have C1 interacting with anion 2. And then I'll have cation 2 interacting with anion 1. Now, what can sometimes happen here is one or both of these items can form what's called a precipitant. So let's say it's this one. All right, the precipitant is a solid combination of these two, of cation 2 and anion 1 in this case, right? And that's going to crash out of solution and make this solid stuff. Okay. Now, if we zoomed in on this, right, what we would be looking at is whereas initially the cations and the anions are separating from each other, we would have cation 2 has its little plus charge, and then we would have anion 1, and it would have its little negative charge. And the interactions between these guys, especially within the context of whatever solvent we're working with, would be such that they would form a solid bond, a steady bond, right? And so then because of that, they would form a nice solid that would crash out of solution. Okay. So again, and I mentioned this in lecture, but I want to reemphasize here that it really depends on the solute and the solvent whether or not something is going to stay in solution or crash out of solution. Okay. And this is why we don't really have like a hard and fast set of rules for solubility across all different solvents, right? Because depending on the type of solvent that you have, something will either solubilize and break into its requisite ions or it won't, right? So it really depends on the solvent. Specifically, what we're talking about, however, is is what's being soluble or insoluble in water. Okay. Now, I kind of butchered it last time we spoke, but I'll see if I can clear this up a little bit better now. The best way to memorize these sorts of things is with the help of an acronym. So solubility. Solubility. All right. Solubility rules. Let's finish out the phrase, I guess. Right. So within things that are soluble, the best way to remember this, or at least is the best way that I can find, and I didn't use this, but apparently the interwebs uses this. And so we're gonna use that because actually I find it really helpful. Okay. Is by memorizing the acronym NAG-SAG. NAG-SAG. Each one of these corresponds to a certain type of thing that is soluble in water. Okay. So the first batch here would be nitrates. Okay. So anything with a nitrate attached to it, and that would be an NO3. Anything with a nitrate attached to it, that's going to be soluble in water. Next up, we have our acetates. That looks a little something like this, CH3, COO. Okay, the charge on this one is, I want to say it's -1, but I don't want to lead you guys astray here. Yeah, it's just a -1. Okay. So -1. So anything with a nitrate, anything with an acetate anion, that's going to be soluble in water. Okay. The next set would be what would be called just group 1. Okay. So group 1, that's going to be anything that has, or that's in our group 1 on our periodic table. So this would be things like sodium, lithium, things like this. These are, broadly speaking, these are going to be soluble in water. Okay. Next up, we have sulfates. Recall that sulfate looks a little something like this. SO4, that's 2 minus. Okay. Next, we have ammonium. That's NH4. And finally, we have halogens. So that would be things like chlorine, bromine, etc. This does not include fluorine, so not fluorine. Okay. So NAG/SAG, N for nitrates, that's always going to be soluble. A for acetate, always going to be soluble. Group 1, for the purposes of our discussion, always going to be soluble. So that's going to be sodium, lithium. So NAG. SAG is sulfate, SO4, going to be largely soluble. A, ammonium, for all the purposes of our discussion, anything with ammonium in it is going to be soluble. And then G, halogens, right? So that's largely going to be soluble. Now, there are some exceptions for this. Oops, hang on. Come back here. Now my whatchamacallit, my computer's freaking out. Don't freak out, computer. Okay. Now there are some exceptions. Let's see if you can see them. There are some exceptions specifically for the sulfates and then for the halogens. Okay. So our first acronym is NAG/SAG. Our second acronym is for the halogens. These are things that when you put them in contact with the halogen, they're going to be insoluble. So halogens are soluble unless they run into the following acronym. And that would be PMS. P would be for lead. M would be for mercury. And S would be for silver. Okay. PMS. That's our way for remembering the things that are not going to be soluble when paired with a halogen. Okay. So whereas sodium chloride, NaCl, is going to be soluble, sodium bromide is going to be soluble. As soon as I click in anything from PMS into the halogens, that's going to be insoluble. So these insoluble. For the sulfate side, we also have a couple of exceptions. The acronym for this one is Castrobear. Okay. Ca, that one's pretty straightforward. That's calcium. Str, that's for strontium. And then Ba, that's for barium. So calcium, strontium, and then barium. And all of these guys are in the alkali earth metals. Okay, so we're gonna take this from the top. In order to figure, the way that we approach this is we figure out, okay, what are the things that are soluble? Okay, we start looking for, and if it has any of these parts of the acronym NAG/SAG, we're going to assume that they're soluble. Then we're going to look for the exceptions. So when I'm asking, is this thing soluble? Does it have nitrates? Does it have an acetate? Does it have a group 1, so like sodium or lithium, right? Does it have a sulfate? Does it have ammonium? Does it have a halogen, right? If it has one of those things, right, then you can just assume that it's going to be soluble. The only exceptions are for the S and the G right here. For the halogens, right, the only exceptions to halogens would be the PMS exceptions, right? If it's paired with lead, mercury, or silver, it's going to be insoluble, right? Otherwise, the halogens are always soluble. As far as sulfate is concerned, if it's paired with anything from Castrobare, so calcium, strontium, or barium, right, then those are also going to be insoluble. So you can assume that all the stuff from NAGSAG are soluble unless they run into PMS or Castrobare, the well-known communist bear. Okay, so I think that's basically it. In terms of things that I primarily want you guys to focus on, it would be the Na and really the Ag, right? Group 1 sulfate, I don't care as much about, right? What that means then is in terms of secondary acronyms, the PMS one is going to be the most important one. Okay. So if you're in terms of things that I want you to memorize, primarily it would be nitrates and acetate. Understand the rules there. And so those are always soluble, right? And then ammonium and the halogens. Ammonium's always soluble for the purposes of our discussion here, right? And the halogens are always soluble unless they're paired with PMS. Okay. So that would be the primary stuff I want you to memorize. And then if you're feeling spicy, you can go on to group 1 memorization and then the sulfate memorization. If you have the sulfate memorized, then you memorize the Castrobare along with it. Okay. I think that's all we need here. If you guys have questions about this, I think that's probably, I'm happy to answer it. A lot of this is just pure memorization. But I hope that was helpful. Again, if you have any questions, shoot me an email. Then I'll probably have a couple like practice. Obviously, I'll have a few practice problems in this on any worksheets that I'm doing later on. If you need access to worksheets, don't hesitate to shoot me an email and we can go from there. But anyway, have a wonderful weekend, guys. Enjoy, or hopefully you guys can stay warm in spite of all the cold. And I'll see you guys later. Okay, money out.